Okay. So bring your binomial exponent out in front. Keep it in parentheses, though. Divide your log over. Log of 2 over log of 1.03. What would be my next step to solving for x? Jordan? Add 5. So now it's x over 2 equals log 2 over log 1.03 plus a 5 after the fact. Last step, multiply both sides by 2. Now, because my right-hand side is currently a binomial, when I multiply it by 2, I'm multiplying the whole side by 2, correct? So x equals, and I can put that 2 out in front, log 2 over log 1.03 plus 5. So when you plug it into your calculator, make sure you're doing these things in the order that now we kind of slowly progress toward our answer. Or you can just, if you use your parentheses right, you can just type this whole thing in. $56.90. Now, just like everything else, answers can be checked. Watch what happens on my calculator when I go back and I plug in 56.90 here. I have a base of 1.03 raised to the 56.90 divided by 2 minus 5 power. What am I going to get? Hopefully. Why didn't I get exactly 2, Isaiah? Right. I used my rounded answer, so I got pretty close to 2. If I had gone up here and for the 56.90, delete, 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 insert, and I went up and I got that exact answer, again, like, oh dear God. I think I have an extra 9 on the end of that. I'd get exactly 2. Okay? Now, we up the ante one more time. Because why are these different? Isaiah? Right. You have to, before you can log both sides, you've got to get this, just the base to the power, all by itself. So if I'm trying to get this all by itself, what's the first thing on the left-hand side I need to get rid of? Isaiah? The what? First, you have to add 3 over. Good. 4 times 2 to the x equals 20. Then I have to divide by 4 so that I have just my base to my power. And I solve from there. Are we good? And then we would log from here. Log both sides. Bring your x out in front. X times the log of 2 equals the log of 5. So x equals log 5 divided by log 2. What is it, Bo? From nearest hundredth. 2.32. Okay? Connor, look at B. What would you do first? Yep. Divide by 17. Very good. Because this is your base to your power. That needs to be isolated. So divide by 17. I'm just going to leave it 4/17. Log both sides. Now that that is all by itself, bring your x over 3 out in front of the log 5. What are you going to do first to start solving for x from here? divide by log 5. So x over 3 will equal the log of 4/17 over the log of 5. And then multiply by 3. So it'll be 3 times that crazy fraction. Any questions? There's got to be more fun stuff on the back. Oh, of course. Okay. So this is a model that we will use more of. We'll actually have a full day on it. But right now we can use it at the basic level. When things are exponentially growing or decaying, there's an original amount. That's what that is. That it starts at. Then it grows to a certain number or decays to a certain number. That's the final amount. R is your rate of growth or decay as a decimal. So 14% would be 0.14. T is the amount of time that you're waiting for the growth to happen. And P is the period of the rate change. For example, if they told you that something grew by 14% every 1 year, then you would put 1 year here. Sometimes they'll tell you that it grows by 14% every 2 years, so you'd put 2 years here. So these are both units of time. This is the amount of time that you're waiting to see how much it grows to become. This is the period of time that the rate coincides with, okay? So for this first example, a biologist is modeling the population of bats. Great. When he first starts observing them, there are 104 bats. Where do you think that 104 goes? A sub 0. Initial. The biologist believes that the bat population is growing at a rate of 3%. Where does that go? R. 3% is your rate. 0.03 we will use. Per 1 year. 1 is where the P is. That's your P equals 1 year. That's the period of your rate change. So when we go to solve this, write an equation for the number of bats, B of T, as a function of the, okay, so B of T equals, the number of bats equals, A sub 0 is 104 bats, that's how much we start with. Now the plus or minus is because you're either growing or decaying. What's happening to the population? Is it growing or decaying? So you use plus. Our rate is 0.03, and we're writing this as a function of the number of years, so T over 1 year, because 1 year was our rate growth. Got it? Now part B says, and we'll actually use this equation, algebraically determine how long it will take for the population to reach 200 bats. So this, 200. In the meantime, 1 plus 0.03, I'm going to make 1.03. T over 1, I can just make T, correct? What do I have to do first to solve this? Just like we did on the front side, eh? Divide by 104. Then what do I do? Log both sides. Excellent. Then what do I do? Bring the T out in front. Excellent. Then divide by log of 1.03. So I have a minute. I'm going to fly through that. Hopefully you already got started. Divide by 104. I'm just going to leave it 200 divided by 104. Log both sides. Bring the T out in front. So log of 200 over 104 equals T times the log of 1.03. Divide by the log of 1.03. So T equals that. Anyone do it? Log of 200 over 104 divided by the log of 1.03 to the nearest year, 22 years. It will take 22 years for that to happen. Just reading the word problem, plugging in the numbers where they go, solving. Okay? Have a great break. Hold on. Your homework I gave you, and you have, remember, you have 2 sets of corrections that I handed back yesterday. That's not factorable, so I'm going to have to take another